right, pressing on, we want to be able to find an equation of the line. Let me fix a typo really quick. So we want to find an equation of the line given the slope and a point. So in this scenario, one starts with the slope and a point on the graph. There are two valid methods for finding the equation of a line in this scenario. So method one is using the slope-intercept form. So when you look at the slope-intercept form, we've got y equals mx plus b, given the slope and given a point. So when you look at what's given in the slope-intercept form, you have the slope, but you're missing the y-intercept. So what you do is you substitute your givens into the slope-intercept form. So this is given, and this is given, leaving the y-intercept as your only unknown. So as I've said before, one equation with one unknown means that this is solvable for the one unknown, the one variable that's unknown. So after you substitute your known slope and the known point, you will be able to solve for your y-intercept. Okay, and once you solve for your y-intercept, you can put it back into the slope-intercept form with your given m and your newly solved b, and that gives you the slope-intercept form of the equation of a line that has the given slope and goes through that particular point. Okay, that's one method. Another method is called method two, and this is using a different form of a linear equation. It's called the point-slope form. So the point-slope form looks like this. So it's y minus y1 is equal to m times x minus x1. So x1 and y1 is a given point on the line, and m is just a given slope. So what you do is you just substitute these givens that you've got into the point-slope form. So you can see we are given the slope, so we can put that in. We're given a point, so we have x1 and y1. And now the unknowns that you have are x and y. So you might be thinking, well, doesn't this cause a problem? Because now we have one equation and two unknowns. Okay. So this is not a problem in this case because we are not trying to solve for x and y. We only need to put this in y equals mx plus b form. That's it. So we just have to do some algebraic manipulation to rearrange this and put it into y equals mx plus b form. So that's kind of what I've said here. So you distribute the m to both terms inside the parentheses. Okay, and that's what we've done here. You combine like terms, and that allows you to simplify it into the slope-intercept form, and you're done. So what we'll do here next with an example is we'll use an example of both methods. All right, so here, find an equation of a line with the slope -1/3 that contains the point 6, -4, and write the equation in slope-intercept form. Okay, so here with method one, we are given that we've got a slope of -1/3, and we've got a point on the line 6, -4. Okay, so 6, -4. This is going to be our x and y that we're given. So method one, we're going to start with the slope-intercept form, and we're going to substitute what we know. So we know the slope, and we know x, and we know y. So we're going to substitute our slope, our x, and our y, and then we'll end up solving for b. So our y is -4. Our slope is -1/3. X is 6, and plus b. So now what we're doing is we're going to be solving for b. 3 goes into 6 2 times. So we have -4 equals -2 plus b. Add 2 to both sides. And so b is going to be equal to -2. So now we just combine this newly found y-intercept with the slope that we were given, and we get y equals -1/3 x minus 2. Okay, so that's using the first method. Now using the second method, all right, so we have our slope and we have our point, like that. And our point is going to be x1, y1. All right, so this is in the point slope form. So the point slope form is going to be y minus y1 is equal to m times x minus x1. All right, so we're going to be taking our known value of slope, putting it here, and x1 there, and y1 there. So we're going to have y minus y1, which is -4. That's equal to m, which is -1/3, times x minus x1, which is 6. And again, to help you make sure that you do things, that you don't miss a negative, and that if you need to go back and check and see if you made any mistakes, make a habit of always putting values that you substitute in, put them in parentheses like I did. All right. Because it would be very easy if you didn't do this to maybe miss a negative here. All right. So I do that for a reason. I'm trying to model, good problem solving behavior practice here. Okay. All right. So negative times a negative is a positive. So we've got y plus 4. Now we're going to distribute this -1/3. So we'll have -1/3 x, and then we're going to have, let me put plus, a -1/3 times a -6. So we're going to have, let me go ahead and move the 4 to the other side. And so we're going to have y equals -1/3 x. And let's see here. So 3 goes into 6 2 times. And then a negative times a negative is a positive. So that's going to give us a +2, then -4. So we've got y equals -1/3 x minus 2. So we got the exact same answer between these two methods. So both are equally valid. I personally kind of like this one better. This is my preference. Because then it's like one less equation to remember, or one formula to remember. But again, they give you the same answer. So whatever you feel most comfortable with.